The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
All right, my name's Gene Stevens. I'm very happy to be here this morning, and thanks for being such a large crowd. This is very, very nice. I'm a little more intense and a little more sentimental than the other speakers, so you're going to see some of my heart come out for Tony here. I've known Tony for a long time, and he was very instrumental in promoting me to get involved with ACI and more involved with what's going on in repair committees. So I really welcome the opportunity to speak with you. These are lessons learned from a master in concrete repair, Tony Murray. I'm going to present some of the projects we've done with Tony, and there's a number of them. It starts very early on, but initially concrete repair session honoring the contributions of Tony Murray. And Tony had a lot of contributions. They extend far beyond, for me, the projects. He was always greeted me with a smile and a handshake, and a very good gentleman. We trusted each other and had faith we could depend on one another. He inspired me to reach further and to go further with my engineering. He made me a better engineer, but he also made me a better person. And I thank him for that. Here's to Tony with many thanks. First project. This is a water tank in Los Animas, Colorado, a diameter 130 feet. There are 12 interior columns, 16-inch square. The slab that is the roof slab is 7.5-inch thick post-tension slab. The water tank sits on the ground. This is a plan view drawn by Jim Harris. And Jim was the project engineer on this and principal. The exterior wall is 20 foot high. It was built in the late 70s. So Jim goes out and looks at this project because there's some distress showing up. A roof slab distress in 1986, spalling in the underside of the columns. Very unusual. Cracks in the top of the slab, in between the columns. And there's low spots also in the slab. Unusual set of circumstances here. Jim looked at the design and saw there was very thin, the stress over the interior columns, and top cracks, like I said, very unusual. So he got Tony Murray involved. Engineering needs, what are we looking at? What are we going to do? And construction techniques. So what are the engineering needs? Define what the damage is, what's deteriorating or distressed, and why. Why is this happening? So Jim goes out there and he puts his knife down on the slab and measures cracks. And he sees some of the top cracks are closed and some of them are open. Strange. He looks underneath the slab, and these are photos shot from way down below. The underside of the slab is spalled at the bent rebar that are coming up into the slab from the column below. The slab was lifted by water inside the tank, and it was actually lifted off the columns. What happened was there was a pump that was pumping water into the tank that was turned on and by a fire that occurred and had a higher capacity than the overflow valve would allow for. So it's pressure vessel. Design did not anticipate upward pressure, of course. So we've got some serious issues here. Now, what's going on? So Jim's primary concern is the spall at the columns is about halfway through the thickness of the slab. Shear capacity is, he calculates with a fee of 0.85 because this is 1986, 79 kips, and a shear demand of 74 kips without any load factors. That's just the weight of the slab. If you look at it today using load factors and the fee factor of 0.75, you have a demand to capacity ratio of 1.5. In 562, we look at that and we say, that's a serious problem, particularly for punch and shear. Seriously unsafe conditions as a result of lack of redundancy to resist the slab dead load. So what do? Well, nowadays we would immediately shore possibly, but at this time we looked at it and we said, we need to get this thing repaired as soon as possible. Let's put in some column capitals around these and to restore the punch and shear capacity. This is a section of what Jim actually sketched. And this is the use of pre-placed aggregate. And the idea was to use this to reduce the potential for shrinkage, causing gaps between the existing concrete and the new replacement concrete. This is construction technique, and this was suggested by Tony. Simple section or through that capital shows you how big it is compared with the column. And today I would say that there's less pre-placed aggregate used than there was in the past, partly because of the use of shrinkage compensating, self-consolidating concrete, but not in 1986. Tony worked as a consultant to us, and his firm Restruction did the repairs. So we were really looking at doing a good job with this, and I should note the reinforcing in that capital would be very hard to place. If you can see what's going on there, you can't get them in around the column. Next project is more the typical type of project, and I present this because this again is a 1986 project where J.R. Harrison Company is doing half cell testing on a very small portion of an exposed concrete deck. Has both twin T's and structural slab. And the reason is this is the sort of typical repair, but it leads to other things. Exposed concrete deck, double T's and structural slab. Restruction did the repairs. Repairs consisted of epoxy injection, expansion joint repair, removing and replacing concrete above the structural slab for some of the corroded reinforcing, and removing and replacing concrete and adding reinforcing bars, epoxy coated bars over the double T's. Like I said, this is more the typical type of repair that we did with Restruction in the 80s. This, on the other hand, is a project where Restruction was helping me do an investigation. And what I'm doing is I'm looking at Terminal Garage in Denver. This is a very old garage designed based on 1928 provisions. It has not only chloride contamination, but it has carbonation that has taken place. And these are beyond the limits of what we know we can control. So very high levels. It has both interior and exterior concrete parking garage, a 10.5-inch structural slab, very thick for the column spacing, two-way system, and you're going to see some of this reinforcing. It's massive. Look at the number of bars that are in this concrete. When I looked at and checked the strength that was required, and old loads were less than what they are today, I found some astonishing numbers. But here, what we're doing is we're removing 3 to 3.5 inches of the existing concrete down to and or below some of the top reinforcing, but not all of it. And we're going to add bars and do repairs here. And Tony's idea was you've got to be consistent with proper assessment to do proper repairs. It's a great idea, it's a good concept, and it's one that we use all the time. The owner is seeking a 20-year safe life on this structure. The slab itself is covered with about 2 inches of asphalt. So we can't see the concrete. We have to remove the asphalt before we can. What we can see is we can see cracks in the top of the asphalt, and we know from that when we take the asphalt off that the concrete has spalled and it's right over the top of reinforcement. This is what it looks like when you start to take the asphalt off and the concrete below. It's just pulverized. Using full bar areas that were on the drawings, and I did have drawings, so it's very good, we've got 2 to 3.5 times the required reinforcement. That's why the structure is still standing up, really, before there were any repairs. And if you look at the picture in the lower picture here, you can see bars running 4 different directions. It's kind of unusual. I got 4 layers of bottom reinforcement bars. Shear is not an issue because of the size of these capitals. These are huge. They are approximately 7 feet across. And interestingly, the concrete below the reinforcement, when we got down to this, is solid. I mean, there's just, it's great. Good aggregate and good concrete. We limited the repairs to isolated areas and high stress over the columns based on a survey that we did. And we just provided reinforcement at those particular areas. And we provided enough reinforcement to take the full moment capacity for negative bending. We use 1/4-inch diameter stainless steel screws to enhance our horizontal shear capacity here because we couldn't get quite enough shear that I could rely upon. The assessment was in 2008. Bottom reinforcement, like I said, existing was adequate. This is the top steel. This was restructuring. Doing this, we open this up and you can see the square edges like Bruce showed you. So we took this down to solid concrete, and we did these repairs in 2009, 2010. Restructuring did some of them. Rohr Construction Company did the others. We reviewed the performance in 2015. We're going to look at this every 5 years. Replacement concrete is solid. There's no cracks. There's no bonding separation. Of course, we could only look at a few areas because, again, we have to take off the asphalt to look at them. But you can see I'm standing on some, when I was thinner, some the nice concrete there. Next check would be in 2020. This is a small project that I did with Tim Gumina, who's the president of Restruction. And it just shows the type of approach to assessing the project with the help of Restruction. We're looking at it, we're investigating it, and what repairs are necessary. What you see in the photograph is the support for PT slab on a concrete beam. The ledge there has been taken out and is being replaced. Those anchors you see with the nuts on the end of them are epoxy installed anchors, fairly close. It's a 2-way post-tension slab, evidence of 1-strand fracture, cracked and spalled concrete in the underside of the pore strip between the post-tensioning, corrosion in the bottom bars, and distress in the concrete supporting the post-tension edge. Now, this is Tim working with me on this project, but we're looking at what's a proper assessment based on what Tony would have us do and determining what repairs are necessary. This is the top of the slab. You can see the blue lines are the sheathing on the post-tension strand, and they actually look pretty good. Top reinforcement looks really good. And we didn't end up doing any repairs on the top because we didn't see any reason to. It looks pretty good. There's not a lot of cracking. The bottom, on the other hand, of the pour strip was another story. And we had to remove and replace the pour strip in the garage. We removed and replaced that ledge that I was speaking of, and we replaced one of the post-tensioning strand. That was interesting to me. I didn't know that you could pull a strand that was somewhere on the order of 150 feet. It was broken somewhere in the middle, and they pulled it out and replaced one strand. Designed by me with J.R. Harris in 2004, and Restruction did the repairs then. This is another project that was actually done by Mike Valley, and I don't know whether you know Mike, but he's works for one of the engineers firms, a larger firm now, and does bigger projects. But this was an assessment by J.R. Harris in 1995, and the repairs by Restruction. This is kind of a unique project. It's a courtyard, and it has a U-shaped building around it, concrete pavers or stone pavers over the top of the concrete, which made it very hard to understand how much distress and how many problems we were going to have with this problem. We had to remove the concrete pavers. Assessment completed as repairing the project, partly at the owner's request. We did a set of drawings that showed repairs, but we worked with Restruction on what else was necessary. This shows you the U-shaped building here in the lower photograph. This was after the repairs had been completed, but it's the only picture I could find that showed you the real courtyard issues. All the entrances and exits to the building are in this courtyard. So we're doing repairs of an entire slab area, and yet we have to provide access to the building and emergency exits. The underside of the underside of the slab showed significant bar distress from water leaking through the slab. Distress on the underside resulted from leaking of the water. We could see this. We knew this had to be repaired. Beams and slab bars were severely corroded in a number of areas. Chipped out areas of unsound concrete, removed and replaced partial or full depth repairs here. The lower picture is a picture of the reinforcing at the end of one of the beams next to a column. And once we got done with these repairs, we of course had to add a membrane in order to protect it. We added epoxy-coated bars in the patched areas, new slab reinforcement, and completely replaced the ramp for the stairs. An interesting feature, perhaps I can point this out a little bit, is this was the way that we provided access to the building, and we would remove this ramp and we had it on rollers and roll it back in place so that people could get in and out of the building. And this was a Restruction or Tony Murray idea, and this was really a collaboration project where we worked together. This is the first picture I could find of external post-tensioning. External post-tensioning, these are the number 2 Denver Highlands structural strengthening of double T floor members with external post-tensioning. I'll explain to you a little bit about what's going on here. This shows a section of double T leg. These bars across here are Dewey dag bars. And you see the shape of this is to pull up on the double T so that we can increase its capacity. Span was 50 feet, 24-inch deep double Ts. Live load increased from 50 pounds per square foot to 83, which was for filing area loads. Added 2 5/8-inch diameter Dewey dag bars at each leg. It was designed in 1986 by Stan Smith and checked by us. Remedial work was installed by Restruction. Now this led to a number of other projects. It was inspired by what Stan and Tony came up with for this particular project. And we've extended this to other projects. This is Village Lofts repair in Denver. And these repairs, I'll take you through a little bit of this. These are steel corbels that were to support at the columns the post tension. And this post tensioning system was not very unique, really, except for the fact that it went through the outside walls. So we're going to take steps here from 86 from the first external post tensioning to 2014 and the current project that I'm working on and haven't finished, but restructuring. We'll know whether they're going to be the contractor next week. They're bidding it right now. This was a 2009 assessment. We found several beams with deficient reinforcement, positive. It was a drafting error. The drafter wrote number 6s when it was designed as number 9s for positive reinforcement in the bars. Pretty significant error. Most cost-effective repair was external post tensioning. And I ended up using the design based on the 2013 562 code, and restructuring did the repairs in 2014. This was a collaboration with Tim and with Tony on how we were doing these repairs. These corbels were bolted on to the columns on each side with a through bolt. That through bolt was high strength, and this was really their suggestion to use 2 1-inch diameter ASTM A354 grade BD bolts with an ultimate strength of 150 KSI. These are all thread rods put through the column. Problem, of course, was locating the existing reinforcement because I didn't and couldn't cut that. And we had to position these accordingly with properly constructed plates and the fit up of the surfaces. Concrete surfaces are not completely uniform, and plates are pretty uniform, and we ended up doing some injection of the surfaces that didn't align completely. This was completely construction technique that made this work. The evaluation information, just to give you a quick explanation, this is a plan view of the slab. These are the corridors that run down the slab. That's showing this because the framing runs into both sides of the corridor. These are the 3 beams that were under designed, and the external post tension goes on each side of those. Spans of the floor and the roof trusses are to the corridor walls that come down and load these beams. Just same sort of model, only showing it 3D, so you can see the span is just from these exterior walls, interior columns. So it's a very simple system and proved to be fairly easy to design a repair. And I'll show you how simple it ended up being. Of course, some of the roof framing doesn't frame exactly the same way. That's always the case. You've got some oddities. But look at the similarities to the center span configuration of these strand versus the external post tensioning bars that were used in 1986. Almost the same pattern with a double harp there. So I've extended this to now using cables and post tensioning the cables. Of course, the problem now is you have to work around all the plumbing fixtures. And we did. So here's the next little issue. I'll just show you a little bit of the construction technique here for the post tensioning. It's kind of fun to look at some of these pictures. That's the external post tensioning. There are 5 cables each side. And as the construction technology, as the complexity of the repairs increases, it becomes more important to have construction firms that you can trust, because you work with more complex details quality control is more important, and that trust factor becomes a real issue. I'm very thankful, by the way, to having restructured. This is the current project. This is Longmont Civic Center. This office right here is the mayor's office. This is a podium slab that supports it. The podium slab, under investigation, has lost somewhere in the order of 70% of the post-tensioning. That puts it in a rather risky situation. Okay? Fortunately, it was designed in the early 70s, and it has a lot of mild reinforcement in it. Otherwise, it might be on the ground too. So this is the structure. I have an office area here, corridor between it, another office area over here. This is the financial center. This is a lobby area for the offices. And this is the main entrance coming into the city's buildings. This is the exterior post-tension portion of the slab, and it's exposed to the weather, which causes a lot of problems because I've got post-tensioning in two directions, and they're exposed to the weather, causing problems. We've got existing post-tension beams. We've got existing post-tension slab running perpendicular to those beams. We've got some exterior walls. We've got new self-consolidating concrete beams we've had to add. And we've got two-way external post-tension reinforcement that we're going to add. It's been designed, it's being bid now, and that's it. Now, final statement. Tony inspires a lot of people, and he did a great job of that. He taught construction techniques, shared his knowledge of needs, contributed to the repairs of structures with restructuring, with documents like 562-16, and Tony will always be in my heart. Thank you.